name's Paul Knock from Megger Baker Instruments. I'd like to introduce Baker Instruments on the show today here at the MEEE in Dubai. They are two electric motor tester instruments from Baker manufactured in Colorado. There are two technologies that we promote. One is monitoring the electric motor while it's actually in operation. So we're looking at the performance of the electric motor, taking into consideration the power quality, the motor condition itself, and also the load. Those three things are very important to monitor because any one of them could lead to the failure of the motor. So that's why the equipment that we have is specifically designed to test those three parameters on electric motors. Not general power quality, not general motor condition, but all of those three combined, which is very, very powerful for the reliability and predictive maintenance of electric motors. Our second technology is designed to test the internal insulation systems of an electric motor. Now, there are actually two types of insulation in an electric motor. This is a stator that we have to demonstrate the two insulation types in the motor. So we have ground insulation that we measure through the Megger test, looking at the insulation strength to ground. But what's specific about our instruments is we're able to monitor, detect and predict the weakness in the insulation between the turns and the coils. Now, there's been several studies done, and it's a fact that electric motors fail predominantly because of the turn-to-turn insulation breakdown. 80 to 90% of the time, the root cause of electrical failure in electric motors is because of turn-to-turn and coil-to-coil insulation breakdown. So now I'm going to conduct a surge test. The surge test on this particular winding, there's a fault built into it, so we're going to be able to see what happens during the test if we have an insulation failure. Of course, the test equipment can do many other functions such as insulation resistance test, polarization index, dielectric absorption, high pot, inductance, impedance, capacitance, but the surge test is the real test when it comes to the reliability and detecting the main fault which leads to failure of electric motors. So I'm going to skip now just straight through to the surge test. So I'm going to basically build the voltage up just like what an electric motor sees during its startup process. So I'm going to hold the button down to start the voltage, and then gradually I'm going to increase the voltage until I start detecting either a fluctuation or I reach my target voltage according to the standard that I'll be working to. Now, this motor is a 415 volt motor, so I'd be probably testing around the 2000 volt mark, depending on which IEC, IEEE and other recommendations for surge test levels you would use. But this one I'm just going to test up to 2000. Here you can see the signal as it's pushed through the winding from the pulsing of the capacitors in the back of the tester. But we're not seeing any fluctuation here. So this is showing that the test is solid and we're happy with this one. So now I'm going to move on to the next phase. We'll start from 0 again, increase the voltage up gradually until we start seeing some fluctuation. Or not if the motor is in good condition. So you can see here we've got another phase that is balanced. There's no issue. There's no movement on the coil whatsoever. So we're going to move on to the third phase. As we increase the voltage up. Okay, we're starting to see some fluctuation here now. So you can see that on this phase we're getting some movement. The pulse-to-pulse area ratio graph is showing that each pulse, there's a percentage difference between each pulse. And if we're applying the same voltage, and we should be experiencing a very level reading. But if I was to take that up a little bit further, you can see that it's now breaching our level. The inductance is changing, and you can see here that there is an arcing in between the turns So we're finding a fault right now live with this data.